Okay, so here's one more problem. You've got this guy here sitting in a contraption. It's like a seat with a rope attached to it. That rope is going over a pulley, and then the rope goes back down, and he's grabbing onto this rope, right? He's holding himself up. I've got to build one of these things. And so let's label some properties of this system here. So, for example, the mass of the person here, we'll call it M1. Yeah, so that person has a mass of, I don't know, let's say 80 kilograms. Okay, and the little seat that he's in, this contraption, it's lightweight, right? Aluminum or something. So we'll call this M2, and it's 20 kilograms. And yeah, he's able to hold onto this rope and hold himself up by grabbing onto the rope. And so the question is, what's the tension in the rope? Okay, so the way I'm going to do this is I'm going to draw a free body diagram. And I'm going to lump all this stuff together. The person and the chair, we will pretend that they are just one object, right? And so then the total mass is going to be the mass of the person plus the mass of the chair. So that's 80 plus 20. So that's 20 kilograms. All right, so here we go. They are represented by this block right here. Did I say 20 kilograms? 80 plus 20 is 100 kilograms. Okay, and then look at the picture, right? There's a downward force of gravity acting on them. And because I've lumped these two guys together, that downward force, it's mg. And so the total mass is 100, and g is 10. So 100 times 10 is 1,000 newtons. The other forces acting on the system it's the rope, okay? But look carefully at the picture. There are two ropes moving up from this diagram. And you might say, well, wait, it's the same rope. Yeah, I know it's the same rope, but it's pulling up in two different places. So I'm going to have to draw two upward arrows here. And I can label them T and T, okay? And then what next? Well, I know I'm going to write down Newton's second law. Net force is ma. And if this person is just holding the rope so nothing is moving, the acceleration is 0. So the net force has got to be 0. And now I'm going to write the expression for the net force, which is the total upward force minus the total downward force. The way we've been working them, I know you're thinking it's going to be T minus mg, but look carefully at the picture. There are two T's, right? So it's T plus T minus mg is 0, or 2T is equal, minus 1,000 is 0. The total upward force has got to be the same as the total downward force. And since the tension in these two sections of the rope are the same, yeah, he's only exerting half the weight of this whole contraption to keep him from falling down. Yeah, so 2T minus 1,000 is 0. That means that 2T is equal to 1,000 newtons. That means that the tension in the rope is just 500 newtons. Problem done. Yeah, it looked complicated, right? But when you lump everything together into just one mass, it becomes a lot easier to solve, to work out. And yeah, problem done. Okay then.